Open the app, and one slot has to be filled. Behind that slot is a catalog too big to look at, and a time budget of milliseconds. Somewhere in that catalog is the exact item for you. Watch it. We'll follow it for the rest of the video, because the most interesting failure in recommendation is silent. The right item exists, and you never see it. Scoring the entire catalog for every user on every request. No system can afford that. So the job gets split in two. A cheap first stage looks at everything and keeps a few hundred candidates. An expensive second stage looks hard at those candidates and picks the handful you see. Retrieval, then ranking. The whole design hangs on that split, and so does the failure we're heading toward. How do you look at everything cheaply? You don't do it at request time. Embed a billion items the moment you open the app, and the millisecond budget is already gone. So one network, the item tower, turns each item into a vector, a handful of numbers that drops it into a space where nearby means similar. Our item becomes this one. That runs offline ahead of time for the entire catalog. A second network, the user tower, turns you right now into a vector of your own. The score between you and any item is a single dot product. The two sides never mix until the final dot product, so the item side can be computed early and stored. The expensive part happened before you ever open the app. All those item vectors go into an index. Ours now, 1 point among millions, built to answer one question fast. Which points score highest against this one? Your vector drops in, and an approximate nearest neighbor search pulls out the top candidates. Approximate is a choice. The index has a dial, a little more accuracy, a little less speed. Somebody set that dial on purpose. Remember that. It becomes a suspect in a minute. The candidates go to the ranker. The ranker gets to do what the first stage never could. Look at you and the item together. How much of this channel have you watched? How long since you last touched this topic? None of that fits inside a dot product between two separate vectors. The ranker computes it directly. That's exactly why it can't be pre-computed and why it only ever sees the shortlist. Scores sort, the slot fills, and everything looks fine. Except our item isn't in that shortlist. Rewind. The item that was right for you sat just outside the candidate set. The ranker never saw it. It can't rank what Retrieval didn't fetch. Nothing crashed, nothing logged an error. Every stage did its job perfectly on a shortlist that was already wrong. When you wonder why the app never shows you something you'd love, this is where it can die. Silently, before ranking ever runs. First suspect, that approximate search. Maybe the index just dropped it. There's a clean way to check. Swap the index out and score every single item. Brute force, no shortcuts. Still missing. So the index is innocent. The model placed our items vector too far from yours, and the geometry came from training. That geometry gets set in training by examples. Items a user engaged with get pulled up. Everything else needs pushing down. Those are the negatives. The standard trick is to use the batch itself, the small group of examples the model trains on together. While it trains on your click, the other items in that group play the negatives, which means the model can only push down items that actually show up in the training data. An item with no engagement anywhere never lands in a batch, so it never plays a negative and never gets pushed down. So the junk floats. At query time, that junk still carries scores it never earned. It crowds the candidate set and our item loses its seat. The miss was deciding before you ever open the app. The repair goes into training. First, stop drawing negatives only from the batch. Mix in random items from the whole catalog, so even an item nobody's touched gets drafted as a negative and pushed down. That's mixed negative sample. Second, a companion correction. A popular item keeps getting drafted as a negative, batch after batch, and its score gets unfairly dragged down. The logQ correction cancels that out. Run it again. The junk sinks. Our item clears the cut, reaches the ranker, and the ranker does the one thing only it can do. Look at you and the item together. The slot fills, and this time it's right. Retrieval's job is recall. Don't lose the good item. Ranking's job is precision. Put the shortlist in order. When a recommendation goes silently wrong, suspect the shortlist first. The item may never have made it that far. The same mechanism, vectors, and index, nearest neighbors, is how AI systems search documents. That video is on screen now.